Last night, something happened above our heads that almost no one on Earth noticed, but it made NASA scientists freeze mid-briefing because for the first time in more than 20 years, an invisible system that protects this planet quietly crossed a line. It was never meant to cross the Van Allen radiation belts. Those massive unseen rings of charged particles wrapped around Earth like a cosmic shield are no longer just active, they are fully saturated, overloaded. According to space weather, watchers sitting on a razor's edge, one more powerful solar eruption, and that energy has nowhere left to go. If you lived through the Apollo era, you might remember when these belts were first discovered and labeled. As one of the greatest dangers to human spaceflight, something astronauts had to gamble with twice going up and coming back down, but what's unfolding right now is something even the engineers who sent humans to the moon never planned for. Because these belts don't just exist, they charge, they store, they build pressure, like giant batteries in space, and right now, they're holding more energy than at any point since 2003, and the next solar blast could force that energy to fall back toward Earth's atmosphere in a way we haven't seen in a generation. And what makes this moment so unsettling is that it didn't happen suddenly. It's been building silently, storm after storm, week after week, while we were distracted by glowing auroras, viral videos, and pretty lights in the sky. Something far more dangerous was loading above us. And now scientists are quietly asking the same question behind closed doors. What happens if the next storm hits now? Here's what actually pushed scientists into quiet alarm mode over the last 72 hours. Because this wasn't random, and it wasn't subtle. On January 10th, the sun released a coronal mass ejection, a massive cloud of magnetized plasma that slammed straight into Earth's magnetic field, and at first the numbers didn't look catastrophic. Solar wind speeds climbed past 620 kilometers per second fast, but not record-breaking, so most people ignored it. But speed was never the real danger. The real problem was direction. The interplanetary magnetic field tilted southward, and when that happens, Earth's protective magnetic shield doesn't resist. It opens like a zipper, and energy pours in freely. And once that gate opened, the system above us started absorbing everything. On January 11th and 12th, geomagnetic storm levels officially reached G1. Mild on paper, but deceptive in reality, because while people were filming breathtaking auroras across Iceland, Scandinavia, Greenland, and northern Canada, something else was happening far above those glowing skies. The radiation belts were being fed fresh energy, electrons, protons, charged particles trapped and compressed by Earth's magnetic field, and this didn't happen once. It happened repeatedly, storm after storm over months, quietly loading those belts like overfilled reservoirs, and by the time auroras appeared in places like Scotland, where they almost never show up, scientists already knew this wasn't just a light show. It was a warning sign, because every storm injects more particles, and when the belts reach full capacity, they don't just hold steady, they destabilize, and the unsettling part is that nothing dramatic has to happen next. Even a moderate solar blast could trigger what experts call precipitation, a sudden dumping of radiation downward toward Earth's upper atmosphere. And that's the scenario that hasn't occurred at this scale since 2003. And back then, our world was very different. Fewer satellites, less automation, less dependence on invisible systems that now control everything from navigation to food production. And that's why this moment matters, not because of what just happened, but because of what's now possible if the next storm arrives before this system has time to bleed off its energy. Now, here's where this story gets far more unsettling, because this isn't just about one storm or one bad week in space weather. This has been building quietly for months, and most people completely missed it over the last 6 months. The sun has been firing off repeated eruptions, not always massive, not always headline-worthy, but consistent, and every single one of them injected fresh energy into the Van Allen belts, electrons, protons, charged ions, all trapped and compressed by Earth's magnetic field. And unlike storms in the past, this time there hasn't been enough recovery time between events. So instead of draining naturally, the belts kept filling, expanding, contracting, and tightening like a system under constant pressure. And when scientists reviewed the data this week, they realized something rare and dangerous had happened. The belts weren't just active, they were saturated, meaning they're now holding about as much energy as they physically can. that changes the rules completely. Because once they reach that state, the next storm doesn't just add more energy, it forces a release, and that release doesn't go outward. It goes down toward Earth's upper atmosphere and satellites orbiting inside those regions. And here's why experts are uneasy right now. The storm we just experienced was only rated G, 1 mild by official standards. Yet the belt still climbed to near maximum capacity, which tells researchers the system is already primed and unstable. So now imagine what happens if the next event isn't mild. Imagine a G3 or G4 level storm hitting. While those belts are already full, there's nowhere for that energy to go except cascading downward in a sudden burst. And this isn't theoretical. Scientists have seen smaller versions of this before, but never with today's level of satellite traffic, GPS dependence, and automated infrastructure. And that's why behind-the-scenes space weather teams are no longer asking if another storm will happen. They're asking when and whether it arrives before the belts have a chance to safely discharge. Because if it doesn't, the consequences won't show up as pretty lights in the sky. They'll show up as silent failures across systems we now depend on every single day. To understand why scientists are uneasy right now, you have to rewind to the last time the sun truly lost control. And most people don't realize how close we already came in recent memory, because in May 2024, the sun unleashed the strongest geomagnetic storms seen since the infamous Halloween storms of 2003 G5 extreme level events, triggered by a single violent active region on the sun. And what makes this part chilling is that scientists only recently revealed how closely they were watching it. European researchers tracked that region continuously for 3 months using 2 spacecraft positioned at different angles, watching it twist, tighten, and store energy as it rotated around the sun's far side, completely hidden from Earth until it exploded. And when those storms hit, the effects weren't just scientific curiosities, they were real-world failures that barely made headlines because modern agriculture, dependent on GPS, guided tractors, and satellite-controlled irrigation systems, began failing across multiple continents. Farmers lost critical working days, crops missed harvest windows, and losses quietly stacked into the millions. And even more disturbing, railway signal systems experienced interference. Automated controls that are supposed to be fail-safe briefly behaved unpredictably, with reports of signals switching states without authorization. And one researcher summed it up bluntly: this isn't theory anymore. These systems reacted during a storm, and that storm hit when the radiation belts were not fully charged. Now fast forward to today, the belts are already at capacity, and that changes everything because the storm that caused those disruptions arrived when the system still had room to absorb energy. The next major event may not give us that buffer. And this is where the modern world becomes the real vulnerability, because everything we depend on now lives inside or near these charged regions of space. Satellites, GPS, timing, aviation navigation, financial transaction timestamps, precision, farming, emergency services, global internet infrastructure, all of it threads through a narrow, invisible corridor controlled by space weather, and we already know how fragile that corridor can be, because in February 2022, a single, unexpected increase in solar activity caused Earth's upper atmosphere to heat and expand, increasing drag just enough that 49 newly launched satellites were suddenly flying through thicker air. Within 2 days, 38 of them burned up and were lost entirely. And that happened during a relatively modest storm. Now combine that reality with what's happening today: radiation belts already overloaded, satellites already exposed, and warning times that barely exist. Because right now we get about 15 to 30 minutes of notice before a coronal mass ejection strikes Earth. Barely enough time to flip satellites into safe mode if operators react instantly, and that assumes communication networks aren't already affected. And while agencies are working on better monitoring systems, the truth is uncomfortable. The next generation early warning mission won't launch for decades, meaning we're still relying on aging instruments designed for a much simpler technological world. And the quiet fear among experts isn't about lights in the sky, it's about cascading failures where one system knocks out another before anyone realizes what's happening. What makes this moment different from every past solar cycle is timing, because the sun is now approaching solar maximum, the peak of its 11-year activity cycle, when storms become more frequent, more energetic, and far less predictable, and this time, we're entering that phase with the radiation belts already charged to the edge, which is like heading into hurricane season, with levees already full and stressed, and the unsettling truth is that our society is more interconnected and automated than ever before, yet less resilient to disruptions we can't physically see. Power grids rely on precise timing signals. Aviation depends on uninterrupted navigation satellites. Global logistics depends on invisible synchronization. And when those signals degrade even briefly, the effects don't appear instantly. They ripple silently through supply chains, schedules, and systems. And unlike storms or earthquakes, there's no visible damage to warn people. Something is wrong. Everything looks normal until it isn't. And that's why scientists aren't sounding alarms publicly. They're watching carefully, because space weather doesn't announce itself with sirens. It reveals itself through data. Anomalies, glitches, and failures that only make sense after the fact. So here's the question that matters more than the science itself, because this isn't about fear, it's about awareness. Do you remember the Great Magnetic Storm of 1989, the one that knocked out Quebec's power grid for 9 hours in the middle of winter, if you lived through it? You remember how suddenly modern life stopped, and back then, our world was far less dependent on satellites, automation, and digital systems than it is today. So ask yourself this: if a storm of that magnitude happened. Now, with radiation belts already overloaded, would we be better prepared or more exposed than ever before? And if you've lived through past solar cycles, I want to hear your perspective, because the sun hasn't changed, but we have. And the real question isn't when the next storm hits, it's whether we truly understand what's at stake when it does.